So we're going to have a look at this concept of area, and really what we're looking about is the idea of using formulas to calculate an area of a shape. It doesn't matter what the shape is, the skills and the steps is pretty much the same, and that is the first thing you want to be able to do is identify the shape. Once you know the shape, you need to be able to link that to a formula, so you need to know your formulas. So if you haven't already done so, you need to commit them to memory. And then from then you've got three lines. First line is the formula. The second line is where you substitute in the values and you show you're working out. And the third line is your answer. And when you show your answer, you make sure you have the correct units on your answer. So we'll go through that now with a few examples. So to find the area of this shape here. This shape here doesn't show it, but I'll mark it on quickly. All four sides are equal in length. It's a rhombus. So the area of a rhombus. So I've identified the shape, the formula now. Area of a rhombus is a half xy. Or some of you know it as a half d1, d2. So it's a half the product of the diagonals. In our case, this is 1/2 times 3.7 times 5.6, the two diagonal lengths. And that's just a step in your calculator. You work that out, you'll get 10.36 as your answer, and the units are metres, so metres squared. Next shape I've got down here is a triangle, so let's add a few details to it. Let's say the base of this triangle is 8 metres, isosceles triangle with a slant height of 14. So I say it's a triangle, I go for the formula, area is a half times base times height, and anytime I'm talking about base and height, they have to be perpendicular to each other. So I have a base of 8 here, but my height's not perpendicular. So first I need to work out the height of this triangle, and I can do that using Pythagoras' theorem. So if I do that over here, I have 14, I have h. Because it's an isosceles triangle, this line here, right angles to the base, will cut the base in half. This will be 4. So Pythagoras' theorem, there's my right angle, this will be c squared equals a squared plus b squared. C is going to be here the 14, so 14 squared is equal to h squared plus 4 squared. So 196 is equal to h squared plus 16. I'll subtract 16 from both sides. I'll get h squared is equal to 180, and I'll take the square root of that and find h is in fact 13.4, and I'll round off to decimal places, 42. Now I'll store this in my calculator so I have the exact height, and now I'll come back to my area calculation and say, well, area is a half, the base is 8, and the perpendicular height 13.42. So a half times 8 times 13.42. Again, I'm using the stored memory function of my calculator when I push this in, and so I'm going to get area is equal to 53.66. I had 8 metres over here, so this will be metres squared as my units. So 3 lines of working out every time. Here we go, another shape. One that's a little bit more recent, I guess, for you, but this is a sector of a circle. So for a sector of a circle, you need to know the angle in there. There it is, 105 degrees. And you'll need to know what the radius is. So we'll say it's 21 millimetres. Okay. Again, recognise the shape. Write the formula down. Theta over 360 times pi r squared. And then just put your numbers in as you're working in. Your substitution, 105 over 360 times pi times 21 squared. Do the calculations. Area is equal to 404.1, and again the units square millimetres. So regardless of the shape, 3 lines of working out: formula, substitution, answer, including your units. Okay, let's have a look at a different type of question. Find the side length of a square to 4 significant figures whose area is 108 centimetres squared. So if I want to find that side length, then I'm going to, again, I've been given the area, so I'm going to write that area formula down. So area is L squared, is what we were using the other day. So the area is 108. So I can put that in as 108 is equal to L squared. One extra step this time, it's just an equation solving. To solve the equation, I have to take the square root. So L will be the square root of 108. I'll put that in my calculator. I'll get an answer that goes 10.39. Then it goes 230,485 the extra places. It says to 4 significant figures. So significant figures means start with the first non-zero. Zeros in the middle do count. And count 4 places. 1, 2, 3, 4. Look at the next one. 2. So I'll just round down. So I've got that 10.39. And in this case, the units are centimetres because the square was in centimetres squared. 4 significant figures. There it is. 4 not after the first non-zero. Okay. I also have this idea of a composite area, so to find the area of a shape such as this one made up of more than one shape. In this case, what I'm going to do is I'm going to call it area 1 and area 2. Area 1 is a rectangle, so I'm going to take that area 1 and say the rectangle formula is length times width. It's going to be 22 times 10.2. Calculate that through. I should get 224.4 metres squared. Area 2 is a sector of a circle, and again I'll need this angle here. Now that angle is 270, but even easier is to recognise that that's 3/4 of a circle. So it's 3/4 of pi r squared. 3/4 of pi times 7.1 squared. Again, head to the calculator, get 118.78 when you round off to 2 decimal places. Again, store that. We'll keep that exact. But the total area is going to be, add them together, area 1 plus area 2. This area plus this area adds up to 343.2 units of metres squared. Different type of composite shape. This one's got a hole in it. It's got a gap. Something's taken out. So again, we'll have 2 areas, area 1, area 2. But this time, instead of adding to get the total area, we'll subtract. The big shape is a parallelogram. So area 1 for a parallelogram is base times height. Again, checking base and height must be perpendicular, and that's what I've got, a base and a height. So area 1 is going to be 36 times 13, calculator, 468 millimetres squared. Area 2 is a rectangle, length times width, which is just 25 times 5, which is 125 millimetres squared. So my total area will be area 1 minus area 2. If I do that, subtract those two, I should get 343 square millimetres. Okay, again, just want to emphasise 3 lines of working out is what I want to see in your books. You do need to memorise your formulas so you can make that. What's the shape? That's its formula. Sub in, work out. I'm going to do 3 more examples now. And what your goal is going to be is each example is going to have a mistake in it. So I want you to carefully look at the question and watch the working out. And then what I want you to do is to find the mistake and instead in your books write the correct working out with the correct answer. So to find the area of this rectangle, 60 millimetres, 3 centimetres, so the area, formula, length times width, 60 times 3, 180 centimetres squared. Okay, the next shape. Recognise the shape, it's trapezium. Trapezium area is h on 2a plus b. So in this case I've got 13 on 2, lots of 24.3 plus 29.3. If I do that calculation, I should get 348.4 centimetres squared. Finally, the circle down here, This measurement here says 28 metres. So area of a circle is pi r squared, so pi times 28 squared, and if I do that I get 2463 square metres when it's rounded. Okay, something to think about. All three of those have a mistake. Your job in your books now to rewrite them and to find the mistake and give the correct working and correct answer. Good luck.